Hello, everyone. This is Mike Skineski, and welcome to our third webinar. The focus of this webinar is to talk about our new release of OpenCDISC Community 2.0. We're very excited to bring this next generation open source toolkit to all of you. Very quickly about myself, I'm the founder of OpenCDISC, which I started over 6 years ago. I'm also the CEO of Pinnacle 21, which is the company behind OpenCDISC. I also had a great opportunity to work on a number of FDA projects over the last 3 years, specifically the FDA DataFit and Jumpstart projects. These projects are very critical in enforcing high-quality CDISC standardized data, as well as helping medical and statistical reviewers at FDA to take full advantage of the standardized data. Before I begin, just wanted to show you all the different places that you can follow us to get updates about future events and webinars. You also can get the slides, the video recording of this webinar, and one of these links as well. So we have a LinkedIn page, a Twitter page, Facebook page, a lot of interesting articles as well as recaps from these events go on the Pinnacle 21 blog. And of course, you can always find up-to-date information on OpenCDISC.org. During the presentation, at any time, if you have a question, please look at the top left corner. You're going to notice an Ask a Question button. Please use it throughout the presentation. Towards the end of the presentation, we'll take some time and we'll answer as many questions as possible. So if you take a look at the slide, it kind of puts the whole history in perspective for OpenCDISC. Like I mentioned earlier, we started over 6 years ago with the first Alpha 1 release. Came out, I believe, at the beginning of November of 2008. I can't believe it myself, but there's been 10 different releases over the last 6 years that we were able to provide to the industry. And as you can see in the beginning, it started out, supporting only a few standards. We had the SDTM 3.1.1 that we started with. We slowly added, the 3.1.2, Define 1.0, and so forth. But as you can see, the trend in the last half has really changed with the introduction of many new standards. The time it takes to put out a release has really doubled or tripled in many cases. So one of the goals of OpenCDISC Community 2.0 is to switch back to a more frequent schedule. You should be expecting a quarterly release going forward. And a lot of it is due to changes we're making in the way we're developing the platform. So why are we calling it Community and not OpenCDISC Validator? Well, the simple reason is because it's not just the validator anymore. OpenCDISC Community now, it's a toolkit that consists of 4 different tools. Of course, we still have the OpenCDISC Validator, which is the core of the toolkit. There's been a number of enhancements for the validator. The most important one is the introduction of the FDA, implementation of the FDA rules that they released a few weeks ago. We're also introducing a Define.xml tool. It's a standalone tool that allows you to create Define.xml version 2.0. We're also introducing a data converter, and this is a very simple tool that allows you to convert data from SASXPT into Excel, CSV, or dataset XML. And finally, we're introducing clinicaltrials.gov Miner. This is a tool that's very useful for clinical teams or standards development teams, and it helps you retrieve information from clinicaltrials.gov in a useful way. And because we have 4 tools now instead of 1, we had to make some user interface changes. We hope you like those. You're going to see them in a second. And we also introduced some features that allow you to stay up to date. So we have some automatic updates. We have notifications that will help you stay current with the latest standards as well as with updates for the software. Also, keep in mind that OpenCDISC comes in 3 different editions. the community version is the focus of this webinar. This is the open source desktop tool that many of you are familiar with and associate with OpenCDISC Validator. But OpenCDISC also comes in the enterprise version, which is a more robust, web-based, corporate level solution. This is also the same version that is used at FDA. And then we also have an on-demand edition, which is basically a project-level edition of enterprise. So now let's move on to the demo of the software. Well, before we look at the software, let's start first with how do we download, how do we install, and how do we configure it. You'll find the software in the same location that you have found it in the past, the OpenCDISC.org download page. You see that we made some changes to the page. We're trying to clean it up, make the information easier to find. You'll see that there's two primary buttons. There's a Windows download and a Mac download. You'll also, if you're using a 32-bit version of Windows, there's a separate link below for a 32-bit version, so make sure you select the version that's specific to your operating system. When you select the download, it's a zip file, just like in the past. All you have to do to install it is to unzip it, just like before. There's no installation steps that are required. You just unzip it in any location that you prefer. Make sure you unzip it in a location that you have write access, so the reports that are generated are able to be written to the file system. Typically my documents or any other location that you have write access to is the best location. Once you download it, you unzip it, you can just run it. So I'm on a Mac, so I'm going to go ahead and I'm going to run it from my application folder. So if you take a look at the software, the first thing you see is that it has a significantly different user interface, at least from the home page. You'll notice that there's 4 different tools available now. There's the Validator, Defined XML Generator, Data Converter, and ClinicalTrial.gov Miner. You'll also notice that they could be accessed from the toolbar on the left. There's also a very interesting section here called Recent Updates. This is new in this release. As you can see, it has very recent news from the industry, specifically about the release of new CDISC standards. For example, CDISC just released the therapeutic area guide for influenza just 15 days ago. There's also news from FDA that are relevant to our toolkit. Obviously, I mentioned earlier there was a big news about FDA releasing the official validation rules for ZTM. The nice thing about it is you can just click a link and you can follow where that information exists. And any kind of events that OpenCDISC will hold in the future, we'll have a recap, slides, videos available post-event. Those will also be available through the recent updates. You'll be able to browse that information if you're not able to make the event live. So one of the things that I wanted to show you was that there's also a couple of other options on the menu that is make sure that you don't overlook. There's a couple of things. First of all, there's the preferences. The preferences are the various settings that you can set up for the tool. There's the validator settings, which is the report settings that you are familiar with before, which is the name of the report that you can create, as well as the number of messages that you can generate for each issue. There's also performance settings, which I'll talk briefly when I talk about the validator. There's also application settings that you can specify whether you would like to have automatic updates or not. So if you enable automatic updates, the software will be automatically updated with the new releases. So if, let's say we release 2.01, in which we're planning to release probably in about a week, fixing some of the bugs that were discovered in the first week of production use. If you have an automatic updates available, the software will just update, just like you probably saw with Firefox or Chrome if you're using those. If you have it disabled, the software will notify you that there's a new version available, and you'll be able to click the link and download it. So this is a very useful feature just to help you stay up to date. And finally, there's if you ever want to go back and reset everything back to default, you can go ahead and do it from this menu as well. Also, if you want to know where you can find help, documentation, there's the help menu. There's a link to the OpenCDISC website where we maintain all the various documentation. There's installation instructions. There's how to use the various tools documents, as well as how to set up Medra and how to set up SnowMed. All of that information is available on OpenCDISC.org. You also have the Get Support option, which will take you to the OpenCDISC forum, where you can go ahead and ask any question that you might have. There's also a Send Feedback option, which will basically just bring up your standard mail client and allow you to send us an email. If there's an error occurs in the system, so this is basically what happens when you click on Get Feedback. It basically just sends us an email to support@opencds.org. You can send us an email to this email address at any time as well. If you have any questions, if you have any issues with the software. But you can also do whenever you also get the same pop-up if there's any kind of error in the system. You'll be able to send us the details, and please do if you encounter any kind of errors in the system, or if you see any kind of false positives or anything that would help us improve the product, please don't hesitate and send us the information, and any steps that you use to reproduce the issue would be very helpful. All right, so now let's talk about the validator. Let's close on these screens. All right, so let's look at the validator, which is a tool that many of you are familiar with. One of the things that we wanted to do in this release is we wanted to keep it as close to the old version as possible. So anyone who's familiar with using the old versions will find this very easy to use and very intuitive. So there's a couple of things that you'll notice right off the bat. If you look at the list of configurations, that list has changed. One of the biggest things that changed is the SDTM specifications have been replaced by FDA-specific configurations. So we have decommissioned the OpenCDISC validation configurations for 3.1.1, 3.1.2, and 3.1.3, and we replaced them with the implementation of the FDA rules that were published a few weeks ago. You'll notice that there's no SDTM 3.1.2 Amendment 1. We actually discontinued that many years ago. And if you look at the rules that FDA has published, they make it very specific in there that if you are using Amendment 1, just run this version 3.1.3 checks. There's very minor differences between 3.1.3 and Amendment 1. And if you do run the 3.1.3 validation checks, you will get what you're looking for. So make sure if you have Amendment 1 that you use version 3.1.3. Another difference is how you select the files. So you can obviously go ahead and browse the files like you were able to do in the past. You can go ahead and you can select the files from the file system. Or we have this new option now where you can just select the files from the file system, and you can just drag them onto the screen as well. So you have both options, whatever is more convenient for you. You can, of course, remove individual files, or you can remove all files. The define.xml, when you're validating SDTM, is optional. So if you don't have define.xml, the data will be validated against the numerous rules that are in the SDTM implementation guides, as well as FDA-specific business rules. If you do specify define.xml, in addition to the checks I mentioned, we'll also validate that the metadata defined in defined.xml is a match for the information we find within the data. So you can use it before you have a defined.xml or after. It's useful in both scenarios. You also notice the different terminologies or dictionaries. There's one big difference is that we have introduced additional dictionaries. In the previous versions, we only supported CDISC control terminology and MEDRA. In this version, we added 3 additional ones. We added SNOMED, UNI, and NDFRT. The last 3 are currently being used in validating trial summary domain. There's different parameter values, TS values that are dictionary controlled. The last 2 are published either by NCI or FDA, and they're publicly available, they're freely available. So we will provide them, we'll include them as part of software updates. So when new versions become available and you update to the latest version of the software, the latest version of all the dictionaries will be available in the software. There's nothing extra that you need to do. However, for MEDRA and SNOMED, because MEDRA is a proprietary dictionary and SNOMED has some limitations on how it can be distributed outside of the United States. Because of those restrictions, you have to follow some steps found on our website to actually set those up. But those steps are just basically putting files into the right folder structure within the OpenCDISC tool. So let's select our dictionaries. Let's select the defined.xml for the study. I believe it's a 312 study. Let's take a look what happens when we run it. So, it basically works the same way it worked in the past. You will go ahead and it will scan through your data, and it'll validate against thousands and thousands of checks. One of the big things that we have done, it's a big change, huge change in this particular version, is that you'll notice that a lot of the control terminology checks we actually had almost 300 different control terminology checks spanning, every domain, including the questionnaire domain, which probably accounted for more than half of those. Those all have been replaced by just 6 different checks. And those 6 different checks are completely driven by the CDISC control terminology metadata. So as new versions of OpenCDISC control terminology are released, those rules will automatically generate additional checks for additional control terminology. So that's a big change from before, where before we had to introduce new rules for every new code list. That is no longer the case, and as new versions are released, new checks will automatically be generated. So as you can see, I ran the study. As you can see, this is a CDISC sample study that CDISC provided many years ago. That's a fairly small study, and we executed over 14 million checks. So it just gives you an idea of the scope of what happens behind the scenes. Let me show you, before I show you the report, let me show you. You can notice it took about 37 seconds to run. And the reason is because, I was using the default settings. The performance settings is to use, a thread count of 1, which basically only uses a single processor on my computer. One of the most important things you can do in the beginning when you first set up the tool is you want to make sure you set up your performance settings correctly. You have 3 options. In the past, you had to modify the settings of properties files, and you have to modify the client.bat file. Well, we have extracted those properties out into the screen to make it easier for you guys to configure it. The memory options are basically specify the initial memory and the maximum memory that you would like to allocate to OpenCDISC. The initial memory, 256, is the default option. You can stick usually with that setting for the majority of workloads. The maximum memory is what's important. If you're on 32-bit operating systems, I'm sorry, you're only limited to about 3.2 gigs of RAM. So you can only set this, up to 3.2 gigs. But if you are on the 64-bit, you can pretty much use as much RAM as available on your laptop. If you have very large studies, the larger the study is, the more memory you're going to need. So keep this in mind. If for some reason you notice that the software is becomes very slow and unresponsive, that means most likely you run out of memory, and you would want to rerun this with a higher memory setting. And finally, thread count. So you can set this to use as many processors that you have in your machine. Keep in mind, though, when validation is executing, it will eat up most of your CPU power. So if you're planning to do a lot of other activities that require processing power, then you probably don't want this to be set to the maximum. But for the point of the demo, let me change this to 4, which is how many processors I have on my machine. And I'll run the same exact study with 4 processors, so you get an idea of what happens when you configure the performance settings correctly. One of the big things you're seeing is that it's validating 4 different data sets in parallel, where when I ran it the first time, it only ran 1 data set in parallel. And as you can see, I believe it was 37 seconds. Let's see how much it takes this time. Here we go. And it only took 29 seconds this time. Now, keep in mind that your large data sets will be the ones that will determine the overall performance. So if you have a huge lab data set that takes 80% of your data, doesn't matter how many processes you're going to throw at the problem, that data set will take up the longest time and does dictate the overall performance of the system. So let's take a look at the report that was created. So the report remained pretty much the same, but there's only 2 minor differences, or you can say major differences. So one of the big changes is that the header now includes the information about all the, let's make this bigger. It includes all the versions of the various dictionaries that were used for this particular validation. It also specifies the configuration that was used, the define file that was used, if used, and most importantly, specifies the version of the software. So this is great information from historical perspective. If you ever want to go back to an old report, this information will be very useful. Another thing that we added is the publisher ID. This has been prompted by the release of the FDA validation rules. And if you notice, the FDA validation rules, they have published them with their own rule IDs, which is what we refer to as publisher ID. So in order to make it easier for you, I think we lost screen sharing. Let's bring that back. All right, hopefully we're back. So the publisher ID is the IDs of whoever publishes the rules. So if, let's say in the future the rules are published by a different regulatory agency, PMDA, for example, if they decide to publish their own rules in the future, then the publisher ID will represent the ID from that particular agency. Same could be true of CDISC. CDISC, various groups publish their lists of validation rules, and they assign their own IDs. So as we implement their specific validation specs, those will be the IDs used. But the reason we decided to add it as an extra column and not to replace the existing column is because we understand that many people are familiar with the OpenCDISC rule IDs, and it'll be difficult to just switch to a new set of IDs very quickly like this. So for the nearest future, I mean, we have no plans to ever change this, but we're going to always maintain these 2 side by side, so you always can see both of them in every single report. One important thing to so the details tab, you have the same exact, you have both columns available, and same thing with the rules tab. One thing to keep in mind is when you are preparing your reviewer guide, going forward, you do have to use the FDA rule IDs in the guide instead of using the OpenCDISC IDs. So you can use OpenCDISC IDs throughout these reports, but when you do that, please use the FDADs. So let's see. Let's move on to the next tool, which is the Define.xml tool. So the Define.xml tool, this is something that we're introducing as a standalone tool for the first time. In the previous version of OpenCDISC Validator, there was an option to create Define.xml. But that option was fairly limited. Basically, what you could have done is you could have started with your data sets, and you could have scanned those data sets to extract the metadata, the data set and the variables information, and it would generate a Define.xml based on that information. The problem is that Define.xml was incomplete. All right, you still needed to provide your origins, your comments, your methods, your documents, external document assignments. So there's a lot of information. Even the study name and the study description and protocol name was also missing because that wasn't available in your data set. So if you wanted to complete the Define.xml, you had to modify it in an XML editor similar to XML Spy. And that was difficult for a lot of our users. So what we have decided to change in this release is that we have introduced an additional step in the middle. So let me show you. When you go to Define.xml, you'll notice that there's two options. There's an option to create a spec and to generate Define.xml. So the first step is to create what is basically an Excel spec, an Excel template that you can use to fill out the rest of your Define.xml. So let's start with the data, just like we have done in the past. So let's grab that. Let's actually grab the study that CDISC provides as an example for Define.xml. So there's 34 data sets, and I believe it's also 312. So you select your data set. You have to specify the configuration. It's important because this is where we retrieve the standard information, the name, the labels, the data types, and so forth for all the variables. So the process of creating spec basically marries the metadata that we can scan from your data sets as well as the information contained in our configuration files. So you select your data, you select the configuration, and you click Create. And what it does, it scans all the data sets. As you can see, it's extremely fast, and creates an Excel specification. And this is new in this release. Before, it would create a Define.xml directly, which it was hard to modify. Now we create an Excel specification instead, which you can very easily go and fill out the missing information. So for example, the study name, description, protocol name is not available in your data set, so you can go ahead and fill them out yourself. The data set information is available. However, you'll notice that not all data sets had a description. So you should be filling this out here. You should go fix your data set and then rescan. A lot of this information comes from the standard or from the configuration. For example, the key variables, this is very important. This is sort of the generic key variables that come from the standard. This is not your particular key variables, so you should update this per your data. We also generate the variables metadata from your data sets. And if you notice, we do populate the variable, the labels. We also take the length of the actual variables from the XPT files. We also figure out the data type. So if you have, we just don't go by number character. We will scan the contents of the data, and we will, determine whether it's an integer or a float or a date time. But as you can see, a lot of other important information is missing. The origins, the page references, the methods, the predecessors if you're doing Atom, the comments, all of that information needs to be entered, as well as your value level metadata. So what we do is we provide additional tabs in the specific in Excel spec for you to be able to do that. So you have a tab for value level metadata. You have a separate tab for the where clause. So you can build your where clauses and then reference them from your value level. And it also allows you to reuse where clauses. You also have your code list tab. If you notice in the old version, you could provide your code list in Excel spreadsheet. This is basically it. You can just put your code list into this particular tab. You have your external dictionaries. You have your methods and your comments. Now, methods and comments, once you specify them in these tabs, you would then go back to the variables, and you would have to reference them in the method and the comment column. And finally, you have any kind of external document references. So your blank CRF, your reviewer guide, and any other documents that you would like to reference. So the biggest improvement is that instead of having to modify an XML document, you can now modify an Excel spreadsheet and then generate a complete defined XML. So let's see how we can do that. Well, before we do this, let me show you what else we could do. So we just created an Excel spreadsheet from your data. But let's say you already have a defined XML. Maybe you got it from your vendor. Maybe you have some historical studies that you created defined XML in version 1 and you would like to now update them to version 2. Well, we also have an option to import an existing defined XML and convert it to our Excel spec. So let's take a look at how that's done. So let's select the defined XML file that comes from CDISC as an example. So that should be a fairly high quality defined XML file. And we'll go ahead and we'll import it. And you'll notice that when I open up the Excel specification, because the information came from a defined XML document, it's exactly the same tabs, but now they're all pre-filled. So you got your study name, description. You'll notice that your value level metadata has been extracted from your defined XML. You got your where clauses. You got your methods, comments, dictionaries. So if you have an existing defined XML, you just want to tweak it. You're missing you forgot to put in your value level metadata. Or let's say you got a defined XML that has everything except value level metadata. You can just import it, complete the missing information, and then you'll be ready to create a valid defined XML. So let's see how we can do that. So under defined XML, you have also a second option called generate define. So under generate define, it's an extremely simple screen. All we do is we ask you to specify the Excel spec that you would like us to use. So I have one right here. And you say generate. What it does, it takes that Excel specification and it converts it to a defined XML. Now keep in mind that if you're missing information in your Excel spec, it will create a defined XML that's missing information. So you still have to take the defined XML you created and you have to validate it within the validate option to make sure that you haven't missed any information. So that it's not a substitute for that. So I can go ahead and I can open the defined XML. Since I have a XML editor, it's going to open an XML editor. So let me just open it in a browser instead. This is the define that it just generated. So let's just open it up in the browser. And you see a very familiar defined XML using the style sheet that is provided by CDISC. This will be as complete as your Excel specification. If you're interested in a more robust defined XML tool that actually make sure that you complete all the required information, you can look at the enterprise version. It's much more robust and it allows you to do additional things such as scanning, for example, the page numbers from the annotated CRF. But the community version is a good starting point. At the very least, it allows you to create a defined XML by scanning your data sets, filling out the missing information within an easy-to-use Excel interface, and then generating a defined 2.0 based on that Excel spreadsheet. So now let's take a look at the data converter. So the data converter it was actually prompted by a number of users. I was one of the people that were calling for one because I use a Mac, and unfortunately on the Mac, the SES viewer doesn't work on the Mac, so I can't open any SES XPT files on my computer. So it was always a problem for me. I always had to ask somebody to save the expertise as tab delimited files so I could view them. So this was a very good tool just for myself, because I'm not a test programmer, to convert this into something that I could use on the Mac. It's also very helpful for people who potentially want to do some analysis in Excel. Excel is still a very popular platform for analysis. This is a great tool that will help you get there. So how does it work? It's very simple. You basically select your data. So let's see this sample study. The source format so far, we're only supporting SASXPT, but we are planning to add more in the future. And you just have to select one of the three output formats: Excel, CSV, or dataset XML. So I'll show you a few of them to see how that works. You also have to specify the output path. So let's go ahead and create a folder. So let's create a couple of folders. Let's create one for Excel. So you'll basically select your data, you select your output format, your output path, and then you click Convert. And what it does, it will step through all of your data sets. It will extract any kind of metadata that it can find in those data sets, and it will create an Excel spreadsheet, basically an exact representation in Excel. So this should be complete in a second. As you can see, the data conversion many times takes longer than the validation, and that's because there's a lot more writing to the disk operations than validation. Validation all happens in memory, that's why it's so fast. All right, so once it's complete, it actually allows you to click on Open Folder. It will take you to the folder you specify as output path. And if you notice, it created all these different, Excel files. So it basically creates a separate Excel file for every, source XPT dataset. So let's take a look at adverse events, for example. So because we have Excel, we try to pull out all the information from XPT files. So the first tab, let me make it bigger. The first tab basically creates your, it specifies the metadata of the data set. You got your data set, you got your label, and don't be surprised, there's a path. The path is actually the label in the data set. I know I was surprised as well when I first saw it. How many variables and how many records? So you have your metadata about the data set. You also have your metadata about the variables. So same information you would find in the SES viewer. So you can see what variables, what are the data types. You can see which ones have a label and which ones don't have a label. If there's any format that's being used. All of that information gets converted to Excel as well. And finally, you got your actual data. And because this is Excel, obviously you can do some very basic operations such as filtering. This is a lot easier to filter than the SES viewer. So if I want to see, all that has been resolved, I can very easily do that. You can obviously create charts, and you can do whatever you want that Excel allows you to do. And this is what I use on a day-to-day basis. Since I'm not a SES programmer, I find this extremely useful. So now let's take a look at what other formats we can create. So CSV would be identical to Excel, except you don't have the 3 tabs, you only have the data tab. Because CSV, you unfortunately can't have multiple tabs. So when would you use CSV? You would use CSV if the size of your data set exceeds 1 million records, because Excel, in the Excel 2007 and up versions, allow you 1 million records approximately. So what would happen is if you would generate an Excel spreadsheet, it would cut you off at 1 million. If you use the CSV option, it will output all the records. Obviously, you still can't open in Excel because Excel will cut it off at 1 million, but at least you'll be able to process them with other systems that you might, maybe ETL systems or some kind of other analysis tools that can read XPT data sets. Let's take a look at dataset XML. So dataset XML, let me create a new folder so we don't mix them all in one folder. So the one thing is with defined.xml is that you need to have a defined.xml document, because dataset.xml doesn't have any of the metadata. It references a defined.xml document that contains all the metadata about your variables, whether labels, data types, and so forth. So now, how do I create a defined.xml if I don't have one? Well, you have your defined.xml tool. So if you need a defined.xml, go ahead and create your defined.xml first. But once you have the defined.xml, you have to specify it. So let's select, I'm using the sample study, I believe. And it does the same thing it did with Excel, except it will output your dataset XML files. And for some reason, that's taking quicker than the Excel version. All right, let's see what the output looks like. So just like Excel, you have one XML document per original dataset. Let me open up just the one in the XML browser so you get an idea of what it looks like. As many of you hopefully know, dataset XML is a newer format that CDISC has created a few years ago. It's designed to be as a replacement from XPT files. It obviously has a lot of advantages. You don't need to have a SAS viewer to use it. It's easier to read with many other technologies. The only downside is it creates bigger files. So it's typically recommended that you zip them before you send them to your colleagues. And it's currently undergoing a pilot at FDA, by the way. So what does it look like? It's basically a very simple structure. You have your clinical data element, and every record from the XPT file got converted into this item group data element. Each one of these item group data elements has a reference to an item OID, which is a direct reference to that item definition in the defined.xml document. That's why the defined.xml document is so important. And finally, you have the value of that particular cell in the data set. So it's a very simple structure to create, and this just gives you another option of what you can do with your data. All right, so now let's take a look at the clinicaltrial.gov miner. This is our final tool that I'm going to show you today. So what is this tool designed to do? I guess it'll be easier to explain if let's just go right to the clinicaltrial.gov website. So I hope many of you are familiar with this. This is a very large database of all the past and ongoing clinical studies around the world. There's a lot of very helpful information. There's two types of users, at least that I interact with, that can benefit from using the clinicaltrial.gov as well as our miner tool. Those are either standard development teams. So, if you're working in the new therapeutic area, for example, and you want to see, what has been done in the past. Well, let's see. I believe CDISC just a couple of weeks ago they announced that they're working on a new standard for Ebola. So let's see how the standard team could possibly use this. So you can go ahead and you can search for, there's advanced search available where you can search based on many different parameters. You have condition, interventions, what countries the studies are being run, the gender, the age group, the phase. There's every kind of filter that you could use. So let's say I'm looking for patients that have Ebola. Just got to spell that correctly. And if I search within clinicaltrial.gov, it comes back with 23 studies. The problem is, I can obviously browse through each one and I can, learn about each study. But if you would like to extract this information so you can use it outside of the system, it's quite difficult. The download option they give you is basically to download them as XML. And it actually creates an XML document per study. So if you have, let's say, 100 studies or 1,000 studies that you would like to pull out of the system, you got to deal with 1,000 different XML documents that you're going to have to write a program to parse and extract information from. So clinicaltrials.gov is really easy to browse, but it's very difficult if you want to do processing outside of the system. And this is what our tool was designed to do. So what it does is, if I look, if I go back to that search page, you're going to know. So let's return to our search. You're going to notice that in the URL, the conditions. So basically, all these conditions actually get put into the parameters of the URL. Similar to Google, the way if you do search in Google, it will put all the parameters in the URL. So clinicaltrial.gov works the same way. So what you do is you can go to clinicaltrial.gov, build a particular search query, so make sure you get the studies that you want. Then you can go back to our tool, and you can paste that condition right into our tool. Now, we currently allow you to extract two types of information based on that query. You can extract the outcomes or endpoints for those particular studies. And this is something that's very interesting to the standards development teams, especially the therapeutic area teams. So if you want to know all the different endpoints that were collected in prior studies, so you can work on creating a standardized set of those. The outcomes report is highly beneficial. You can basically, we will extract all the endpoints across the studies that match the search query. And you also have a report that will extract all the sites that are actually running those studies. So let me show you both. So I'm going to run, I'm going to get a list of all the endpoints for studies that are running Ebola. They're studying Ebola. So let's take a look what it looks like. So basically what it does, it goes out to clinicaltrial.gov, executes that query, and then converts those XML documents into a much more usable Excel file. So let's take a look very quickly what that contains. So the information that I was interested in is the endpoint. And the clinicaltrial.gov stores the endpoint information in different fields. You have your endpoint title, you have your official title that sometimes have that information. But the nice thing about it is that you can extract all this information to a spreadsheet, and then you can work on, it's much easier to look across studies than you would have to look through, hundreds of XML documents. It's also much easier to, filter. So if I want to say, well, I want to only care about endpoints for phase 2 studies, then it's much easier to do in Excel. And you see we extract, all the information that would be pertinent to this information. So you have your types of studies, you have your, official title of the study. You also have your sponsors that are executing the studies. So if you want to see what all the sponsors that are doing Ebola studies right now, this is the list of all the sponsors that are studying Ebola. So this is very useful for those that are interested in extracting that type of information. And finally, if I just want to see what are the actual sites that are running those, I would just switch to the different report type, and I would execute the same exact operation. So let's take a look at what is being returned now. So this is all the sites that are actually running, that are studying Ebola. And as you can see, it provides the facility name. You have your facility names. You have, in many cases, you even have the name of the investigator along with their phone number and their email address. All of that information is available on clinicaltrial.gov. It's just much harder to extract that information and use it in analysis, or to try to pull this into an internal system for additional analysis. The purpose of this tool was to do just that, is to allow you to extract information from clinical.gov in a more useful format for analysis. And with this, it brings us to the end of the demo, and we'll go ahead and we're going to move to the Q&A session. All right, so let's see. The first question was about prerequisites that you need in order to install the software. So if you notice on the download page, we provide basically 3 different downloads. You have a download for 64-bit Windows, 32-bit Windows, and Mac OS. So you need to have one of those 3 operating systems. We could also create one for Linux. We just haven't done it yet. But we support basically all the operating systems. So anywhere from XP, Windows XP, to Windows 8, and at least the last 5 versions of Mac OS. We haven't tested all the way back more than the last 5 versions. Everything you need comes in a zip file. Even the Java is bundled with the software. So you don't have to install Java. You don't have to have any particular version of Java. Everything is bundled together in the one zip file. That makes it a lot more stable. You basically going to have a lot less issues running this and installing it than you did with prior versions. That was one of the big changes that we wanted to make. So another question was about the dictionaries. So there's a question about WhoDrug. We are actually talking to the WhoDrug folks to add support for WhoDrug as well. So I would expect that being added in one of the upcoming releases. It's going to work, I would assume, very similar to Medra, where we would provide you instructions of how to add WhoDrug into the particular folder in order to make it available through the user interface. Another check was asking us if there's a way to switch checks on or off. This is a very good question. This is a question that we had, many people have been asking us many different years. So let me show you. So this is what the files look like on the file system, so you got your OpenCDISC folder, which has the config folder inside of it. So that's been the same since the beginning, and that folder has all these different XML documents. So if you notice, there is an XML document for each standard that we support. So we have one for Atom. We have for both versions of defined XML. There's 4 versions of SDTM, and there's version for SAN. So those are those XML configuration documents. If I'm going to go ahead and I'm going to open one of these, let's open the 312. There's a couple of things you can do in those documents to enable or disable checks. Obviously, you have to work with XML. If you don't like working with XML and you want to work with the user interface, you should check out the enterprise version of OpenCDISC. It has a rule designer where you can do this all through a nice web interface. But in the community version, you can go ahead in the file, and you're going to notice that, so for example, here is demographics, and you'll notice this is a defined XML 2.0 structure. So if you're familiar with defined 2.0, you're going to be familiar with our XML configuration structure. You'll notice at the bottom of every item group, we have references to validation rules. So this is an extension of defined 2.0. And next to each rule, there's an active yes or no flag. So if you want to disable a particular rule in the particular domain, all you have to do is change it to no. And now the rule is disabled. So it's that easy. Let's see, what's the next? The next question is about the Medra coding case. Okay, so this is very similar. So Medra case has always been one of these issues that many companies would convert Medra terms to uppercase. If you look at the implementation guides from CDISC, they're very clear in that they want you to use the case of the actual dictionary. So if the dictionary uses, mixed case, then you have to use mixed case. FDA have followed up with initially with the CEDAR Common Data Issues document, but then they also followed up with their latest technical conformance guide, where they specifically say that you should use they basically confirm the view from the implementation guide is that you have to use the case of the dictionary. And we used to have 2 checks. We used to have one check that was validate that the term would be missing from the dictionary, and another one that would say that you have it in the incorrect case. and the missing one was an error, and the incorrect case was a warning. Well, with the latest release of the FDA rules, if you notice, that particular rule has been updated to an error as well. And the reason is because of the clinical trial repository, JANUS. Once they load the data into JANUS, in its Oracle database, you know, if you have the same term in many different cases, then they basically have to constantly compensate for that in their queries. So they have to constantly convert everything to a particular case in order for the terms to be consistent. So once you start using software, especially software that's case sensitive, case becomes very important. So going forward, FDA is very specific that they want you to use the case of the dictionary. You cannot just convert everything to uppercase. And you can disable that check, but I highly advise against that. So another question is about when would this be available, this presentation will be available on YouTube. So we are actually working right now on putting the previous webinars on YouTube this week. And our goal is to put this particular presentation on YouTube sometime next week. The question is, where is the source code repository? Great question. This is something we've been working on last night. So we moved our source code repository from Subversion to Bitbucket. So it'd be bitbucket.org OpenCDISC. We are actually going to publish it today. It's still, so if you go to check back later today, we are just pushing the file to it today. So we set up this repository yesterday, but there's no files there yet. And when you go to bitbucket.org/OpenCDISC, there's also going to be a link from the download page. See, we have the Subversion repository. This is going to be replaced later today with the link to the Bitbucket repository. And you'll notice that there's now 5 different repositories. There's, one for there's one for each tool. So that's a different project. So there's different code base for each one of the tools. And then the desktop is the user interface. So you have 5 different projects. All of those will be available. The source code will be available on Bitbucket later today. Let's see what other questions we have. Are all validation needs from FDA included? Yes. So this is a complete implementation of FDA rules. These are also the same exact rules that are executed at FDA, at least the ones that have been approved so far. So the reason we are marking them as FDA, because they're basically the same exact rules that are executed in FDA dataset project. So you could be anything that we mark FDA going forward, that will indicate that this is basically an exact, an artifact from something that is used at FDA. So this is not, an OpenCDISC implementation or a Pinnacle implementation. This is the same exact configuration that is run at FDA. How do we validate defined XML? All right, so let me show that once again. It's quite easy. When you go to the validator, you'll notice that the standard has multiple options for every standard. If you want to validate defined XML, you just have to select defined XML. You can also specify whether you want to validate a 1 or version 2. So let's do version 2. Let's select that defined XML that CDISC provides as an example, and you validate it. It's that easy. All right, next question. When you create the defined XML, the spreadsheet, can you also populate the value level metadata? So we currently have stayed away from doing that because value level metadata is really something that's very study specific. You could generically generate it, for example, for all the test codes, but we don't necessarily know the conditions for all those test codes. Like, for example, vital signs units, for example. A lot of times the units are different per country. So your work clause would be, where test code is height and country is USA, you would have one set of units. When something else, you would have. So because it's such a study-specific metadata, it's very we decided not to try to generate anything at this point, but we'll be looking forward to your feedback to see if there's anything else we could do to improve the product. Will Atom defined XML generator be able to report split? I guess you mean the split data sets? Oh no, the level domain. Okay, the result level metadata. Yes. Okay. So currently, result level metadata. That's currently in draft. Once it gets approved, we'll add support for the result level metadata for Atom. We haven't done that just yet. You obviously have your value level metadata that you can specify for Atom datasets right now, just like you can for SDTM. But we haven't added full support for result level metadata just yet. But this is something that's coming up in the near future. And then finally, final question, do we still support command line interface, being able to execute this in batch mode? Absolutely. Nothing has changed. If you notice on the file system, we used to have a lib folder. The lib folder has the actual Java libraries that you can call from the command line. There's a lot of libraries and the list is growing as the software is growing. But the ones that you're concerned with is this validator CLI. Right, so if you want to execute the validator from command line, you can just run, before you were able to do it against validator CLI, you can continue doing exactly the same thing. We also added a command line interface for the data converter. So so you can convert your XPTs to the Excel CSV or dataset XML. You can automate that process from command line as well. If you want to know how to use it, you just do the help option. When you run this, all of the options will come out on the screen. We're also working on updating documentation on the website for that as well. And the clinicaltrial.gov library, which is this one, it also has a command line interface. So currently 3 of the 4 tools have a command line interface. We haven't created one yet for defined.xml, but that's something that's on our roadmap as well. So just to wrap this up, I would like to thank everyone for joining us for our 3rd webinar. Please, stay up to date with our latest. Once again, this is all the different ways you can stay up to date. Our plan is to hold these type of webinars quite frequently, at least once a quarter, on various topics that either has to do with regulatory submissions or validation or creation of the various artifacts such as defined XML reviewer guide. We also planning to hold at least 3 OpenCDISC live events next year in various locations around United States. So if you want to be notified of these, please follow us on one of these channels and stay tuned for more. Thanks again for your support. Please, once this webinar completes, you'll be forwarded directly to the download page. So please download the software, use it. Let us know if there's anything else we can do to improve it. And any kind of any questions. I mean, there was more questions that I got a chance to answer. All of those will be answered and put up on our blog as part of the recap. Thanks again. We'll talk to you later.